Okay, so we will look at the MCQs related to motion kinematics. So the question number one, the graph shows the speed and which statement was the acceleration in 10 and 20 seconds. So it is delta. The acceleration is 0 between 10 and 20 seconds because there is a slide lag. Question number two, student walks at a constant speed and you need to find out the time it takes after these calculations. So as you can see that it takes 100 seconds to walk 160 paces. This will give you the speed, and then you have a distance and you have already calculated the speed. So you can find the 50 seconds time is the distance covered in 50 seconds with this speed will be 64 meters. And then students, question number three, student drops from rest at table tennis. What happens to the velocity and to the acceleration? So the velocity increases and the acceleration decreases. It is because when something falls down, it starts to accelerate. Okay, the acceleration at the time of the drop is maximum, but as it falls down, the velocity increases, but the velocity increases, but the acceleration decreases because of the air resistance. The velocity is increasing because it is accelerating, but the acceleration, the rate of increase of the velocity is decreasing because of the air resistance it is facing. Then we have cyclist takes ride lasting 25 seconds. What is her speed? And then in this, we will calculate the total distance 150 divided by the total time. That gives you 6 seconds. Car begins to move, speeds up, reaches constant speed, continues to travel at this speed. What happens to the acceleration and the velocity of the car? The velocity and acceleration both change. It is because as it begins to move, the velocity changes. It speeds up, it is accelerating, the acceleration is also changing. Then when it reaches the constant speed, so before reaching the constant speed, both velocity and acceleration change. Here we have object travels at a constant speed, 10 meters per second for 10 seconds, and then during the next 5 seconds, it accelerates. The total distance will be under area under the graph. So we'll calculate the distance of this rectangle, which is 100. And then we have this rectangle, and then we have this triangle. So adding the area of these two will give you 175 seconds. And then a lorry takes 15 minutes to travel along this path. The average speed is the total distance, 8 and 3 and 5. And these are kilometers. So 15 minutes. So you divide the kilometers with, first of all, you convert the 15 minutes into an hour, which is 0.33 hours. And then you divide the total distance with 0.33, you should get 64 kilometers per hour. And then we have at the time T1, stone is dropped from a stationary balloon. The stone reached terminal velocity at time T2. The acceleration is 10 at T1 and 0 at T2. So choice B. Next, question number 9. The graph shows the speed of the car. Which plane shows the largest acceleration? The curve with the highest speed, highest gradient, steepest gradient is A. So that's the largest acceleration. Question number 10. An object falls from rest and the air resistance increases. The object reaches terminal velocity. Which quantity decreases? Well, it is the acceleration. Object falls from rest through the air, its velocity increases with terminal velocity. Which quantity increases until its terminal velocity is reached? Which quantity increases? So it is the air resistance that is increasing, because of which its acceleration decreases and becomes zero, so it reaches terminal velocity. So this graph, which distance time graph represents the journey of this graph? So there is a constant acceleration. The constant acceleration cannot be this one, because this is a constant speed, it is not accelerating. In this, the object is at rest. So it can be either A or B. So the car is increasing increasing speed with a constant acceleration. So it is not decreasing speed, so B is not possible. That is why we have A is the only choice left. Then we have a heavy coin, it falls a short distance. Look at the words short distance. So it does not reach terminal velocity. It is because the weight of the coin is always more than air resistance. So it is always accelerating, because the resultant force is not zero. Car travels along a road at this speed. The driver applies the brakes. And on a wet surface, how many of these distances are greater than on the dry surface? Well, on a wet surface, we will have a larger braking distance, and we will have a larger stopping distance. But a wet road does not increase the sinking distance. So, C. And then in this graph, very simple, skydiver is falling with the terminal velocity, and this part is showing that. So D is the choice. So the graph shows the speed time graph. What is the distance traveled in the 4 seconds? So you have this area under the curve. This is a rectangle. Where this is a triangle. You can add the areas of rectangle and triangle. That gives you 25 seconds. An object moves from P to Q in 10 seconds with uniform acceleration. Velocity at P is this, at Q is this. What is the acceleration? So the velocity increases from 5 to 12 in 10 seconds. That is 0.7. So if we divide it, we get 0.7. So B is the choice. We have a graph showing the height of an object above the ground, changes with time. So it is falling down. Height is decreasing. The terminal velocity. So it is a distance time graph. So this line, which is a constant gradient, it is the terminal velocity. So the terminal velocity is starting from this point. If we calculate the gradient from this point to the last point, we get 2 meters per second. As we can see that this point, it is as you can see that very easily, that this point is coming down to this point, which is the half of 0.5 and 1, and that is 0.75. So 0.75 and 2.5, and then this is the time. This will give you the time, and then the height from here is in the 3 point something. If you calculate it, you should get 2 meters per second. But you don't have to do it this way. You have another way to do it. You can take the gradient as small as you want, but it must be on this straight line. Okay. So anywhere you take the gradient, let's try it from 1 to 2 seconds. So we know the time is 1 second. So from 1 to 2 seconds. At 1 second, it is at 3 meters, and at 2 seconds is at 1 meter. So from 3 to 1 meter, it has decreased 2 meters. So 2 meters divided by 1 second gives you 2 seconds, 2 meters per second speed. And here Well, the car is moving with non-uniform acceleration. Everywhere on a speed time graph, you see a curve like this. This is a non-uniform acceleration. So we have 1 and 2. So C is the choice. And then we have a steel ball is released just below the surface of a thick oil in a cylinder. During the first few centimeters of travel, what is the acceleration? So the acceleration is decreasing because as it moves down, it is constantly facing a resistance of the oil. And here, this question, cycle, a cyclist travels along a sorry, cyclist travels along a hilly road without using the pedals. So he's not using pedals, so he's not applying any force. No air resistance, no friction, and this is the speed time graph. So as you can see that here the speed is increasing, becoming constant, and then it increases a large way. So this is where the cyclist uh, reach the bottom because when it's coming down from the hill, its speed will increase very much. When it reaches the bottom of the hill, that's where the highest speed occurs. And then somehow he climbs another hill maybe, so its speed starts to decrease and then whatever. So this is the bottom of the hill. The next question 22, a ball starts to roll down and which graph best shows the speed of the ball? Well, the ball starts to roll down a steep slope, so it should accelerate and then along a rough horizontal road. So when it starts on the rough road, its acceleration should actually decrease. Okay, so this graph is showing increasing acceleration and then slightly decreasing it. This graph is not possible. In this graph, it doesn't roll with an acceleration, it is moving with a constant velocity, and this one is actually something moving with acceleration and then reaching the constant velocity. So the only option is D. The table tennis ball is released top of elevated table. It goes through the vacuum, so its speed should increase constantly, i.e., it should have a constant acceleration. So A is the choice. The speed time graph for a car is shown like this. What is the acceleration of the car at 30 seconds? So at 30 seconds, the acceleration is zero because there is no more speed increase. Skydiver falling, what is the acceleration during this fall? Well, it starts from 10, we have learned this previously, and it is decreasing to zero when it reaches the terminal velocity. 27, a car accelerates from traffic lights for 10 seconds and then stays steady speed 20 seconds, then brakes in 3 seconds. So this very easily tells you acceleration, steady speed, and then deceleration. And this deceleration is verifying the 3 seconds because the other graphs are showing a little bit more. So this one could be for you, but look at the curve. The car accelerates for first 10 seconds. So it is accelerating for first 10 seconds. This is also accelerating for first 10 seconds. But then 20-second gap is not here. So we have 10 plus 20, 30, but here 10 plus 20 is not. So this is not possible. The other ones are rejected anyway. And then we have the question which is not visible clearly here. So you can do this with your own understanding. So this one, which vehicle has an acceleration of 5 meters per second square? Well, a motorbike, when its speed changes from 50 in 10 seconds, the acceleration will be 5. All other calculations will not give you 5. Look at this, 2.5 meters second in 2 seconds. That doesn't give you more than 2. It is actually 1.25 acceleration. This one is rest to 15 in 5 seconds, 3 meter per second square acceleration. This one rests to 20 and 15, that is also not more than 2. And this one is 50 meters from rest, so that gives you straight away 5 if you divide it with 10. The extra journey made by a cyclist. This cyclist traveled 30 seconds because if you calculate the area, this gives you a rectangle, area of rectangle, area of another rectangle here to here, and then area of a triangle here. Adding these three gives you 30 meters. We have a parachute. We have a parachute in 4 positions. So which have the terminal velocity? If it's not accelerating, so C is the choice. And then we have two-man jump from an aeroplane, same time, one with parachute, one not opening parachute. Why is the man in free fall moving faster? Because the parachuter experiences greater resistance. That's why it's not moving very fast. Student measures the speed of a trolley. At one instant, the speed is 1 and 2 seconds after speed is 4. So it increases by 3 meters in 2 seconds. Divide 3 by 2 will give you 1 point. Sorry, divide 2 seconds later, the speed is 4. So divide 3 by 2 should give you 1.5. And then we have the shaded area, is the total distance covered by the car. We have a stone dropped. Next question. Ball hits the ground, does not rebound. Well, the stone increases speed constantly, but it hits the ground. So this one is not possible. This one is the only possibility. This one and this one are out of scope anyway. This is the machine, the tick machine, and it measures the speed. Which speed does the student obtain? So, what is here? The data tells us that every 0.02 second, the time prints a dot on the tape. First, the tape is pulled quickly, then slowly, then quickly. So, if you pull it quickly, it will have larger gaps in the dots. Then slowly, it will have smaller gaps, and then quickly, it will have larger gaps. All others are not representing this pull. We have a free fall parachute, constant speed, opens the parachute. So, which diagram shows how the distance fallen by the parachute varies with time? So, it should be B because it is moving with the speed and then open the parachute, the speed decreases. Okay, remember this is a distance time graph, so it is not a speed time graph. So the two lines are not acceleration, they are actually constant speeds. Okay. Why these three are not possible? Well, look at A, the object is showing at rest. C is also showing at rest. And in D, there is a constant speed and then the object comes at rest. Okay. Next, 37, graph shows the speed of a runner during this. What is the distance? So if you calculate the area under this triangle, area of this rectangle, area of this triangle, and then area of this rectangle, add them together, you should get 75 meters.